Okay, so we're going to jump into a unit on bivariate data. So the word bivariate can be broken into two parts, the prefix bi meaning two, and the root word variate meaning, in this case, variable. So bivariate data is going to be simply data that measures two variables. And a scatter plot is going to be a graph that is used to represent bivariate data. So down below, we have a scatter plot that is measuring the temperature outside and the amount of sales of ice cream that day. So each data point represents a single day where ice cream was sold and the amount of ice cream that was sold that day. So for example, on this day, the temperature was about 12 degrees Celsius and the sales were close to 200 that day. Now, as you can see, the points do follow a bit of a pattern. So when points follow a pattern, we draw what's called either a trend line or a line of best fit. And what that's used for is it's used to represent the average of a data set. And we do that to make predictions. That's a huge reason why we collect data in general, so that we can make predictions based off of the past occurrences. So for example, if I own an ice cream shop and I know the temperature tomorrow is going to be 20 degrees, I can use my line to predict that I could expect to sell about $450 worth of ice cream. However, with all data sets, we often tend to have outliers. Outliers are data points that don't follow the pattern of a data set. So here, there's an outlier at 22,100 because typically if the temperature was 22 degrees out, I'd be making over $500 in ice cream sales. However, this day I only made 100, and there's always a normal reason or a good reason why that might have happened. Maybe that day there was a storm, so people didn't really come out and get ice cream. It was really rainy, no one felt like getting ice cream that day. But in general, the trend follows that as the temperature goes up, so did the ice cream sales. So the vocab word association is used to describe the relationship between two variables. So here, I drew a little trend line just to help me visualize for these two data points or data sets, the type of association that I have. So since I was able to draw a line, that tells me that this has a linear association with a positive slope. And the points are super close to this trend line, so I would call this a strong association. So we often use multiple associations to describe the scatter plot versus this one, which still is linear and positive, but this one's more moderate because the points are not quite as close to the line as the previous one was. This one in the top right corner would be called no association because that just looks like a random assortment of dots. There doesn't really seem to be much of a pattern. Versus the one on the bottom here, this one does kind of appear to have a bit of a pattern. It's just a non-linear pattern. So we would call this nonlinear, and I would probably call this strong or moderate because the points do follow a pattern closely. It just is a nonlinear pattern. Correlation is another vocab word that we only are going to use if it's linear association. So I love to use this diagram to help me keep things straight. The big category is association. You can always describe a scatter plot as association. You only use the word correlation if it happens to be a linear scatter plot. So all of these are linear scatter plots, so we can use the word correlation. So on this problem, I want to use a trend line to make a prediction. So in order to do that, I need to plot my data points first. So take a moment and pause the video to plot those points in the scatter plot. So now that I have my data set plotted on the scatter plot, I'm going to take a straight edge and draw a trend line through the data. I want to try to have an equal amount of points above and below my line so as to really represent the average of Joyce's data set. And so once I have my scatter plot, I can then use it to make a prediction for how long it would take her to run 4.5 miles. So 4.5 miles is right about there. My trend line comes just below 50. So maybe I would predict 48 minutes. Depending on how you drew your line, you may have something slightly higher or lower than what I came up with. So for that reason, I would like to come up with a way to always be able to find a consistent equation to make my predictions. So that's what we're going to do on the next page. On the next page, I'm going to draw a trend line that goes through my data points somewhat evenly, and I'm going to pick 2 points that are on my trend line. So I'm going to pick the point 5, 50 and 17, 170 to write an actual equation of my trend line. So this graph is linear, and it also looks like it's positive, and I'd say pretty strong because the points are close to the trend line. So the slope of my line, since it is linear, will likely be positive. So remember, to calculate the slope of a trend line, we do y2 minus y1. So let's write the formula, y2 minus y1 over x2 minus x1. So in this problem, y2 is 170, y1 is 50, and x2 is 17, x1 is 5. So I get 120 over 12, which tells me that the slope is 10. So using the slope and the point 5, 50, remembering that points are x, y, I'm going to plug in my slope and my x coordinate and my y coordinate into the formula y equals mx plus b in order to find my y-intercept. So 50 is my y-coordinate, 10 is my slope, and 5 is my x-coordinate. 10 times 5 is 50. So to solve for b, I need to subtract 50 from both sides to isolate b. So my y-intercept is actually 0. So now that I know my two parameters, my slope and my y-intercept, I know that my equation of the trend line is 10x. 10 being the slope, which means that there are 10 pages per chapter in this scatter plot, and 0 meaning there are 0 pages before the first chapter. And then I could use my equation to predict how many pages there are in a book. So if a book is 10 pages per chapter and has 7 chapters, I can predict that it's going to be 70 pages long. And that's exactly what we would want to do here. Interpolations and extrapolations are two different types of predictions that you can make. An interpolation is any prediction made within a data set. So interpolations are inside a data set. So for example, 26 chapters, that is not in our data set. Our data only went up to 20 chapters. So that would be an example of an extrapolation, which is a prediction made outside a data set. So 10 pages per chapter times 26 chapters would be a 260-page book. This is an extrapolation, however, because 26 pages was not inside our data set. However, 14 chapters is less than 20, so the prediction 140 would be considered an interpolation. Interpolations are generally more accurate because we have previous data to rely upon. So we know that we are kind of in the general frame of the data. Extrapolations go outside of what we know, so they're not as accurate because we don't really have data to support it.